Okay, good morning. Welcome. Thank you for joining us. Before we get started, I'm curious to know how many of you have faced database performance challenges? If you could raise your hands. All right. So basically all of you, which is great because it means that you came to the right place. In today's session, we're going to cover performance monitoring and diagnostics in Amazon RDS and Amazon Aurora. And really the goal and the outcome of this session is that you will be equipped with the knowledge about the different AWS monitoring tools and services, and you will learn how they can help you overcome even the most complex database performance challenges. I'm Penny Dibask. I'm a senior database solution architect here in AWS, and I will be joined later by Maxim Karchenko, who is a principal database engineer here at AWS. Before we jump into the agenda, I would like you to take a moment and think about what do these three pictures have in common. We can see here flashlight, radar, and magnifying glass. Exactly. So you basically all guessed it right, I assume. These are all pictures which show tools that improve visibility and detection. And the reason I'm showing it is because I believe it is a very good analogy for today's session. When it comes to database performance, you can't fix a performance bottleneck that you can't see. Let's go to the agenda. We are going to start out slowly by setting some context, telling you a little bit about Amazon RDS, and then we will dive deeper into the various monitoring services and tools that help you overcome database performance challenges. In the second part, Maxim will show you some of the latest innovation when it comes to database performance diagnostics and troubleshooting in Amazon RDS. So you will learn about the newest features related to performance. And we will finish with a real-world example of an online web store which faces performance degradation. And you will see what are the steps we took to address the performance bottleneck and to fix the issue. So it's going to be an interesting session, so stay tuned for that. I assume many of you are already familiar with Amazon Relational Database Service, or Amazon RDS in short. But just to level set, it is a fully managed relational database service. With Amazon RDS, you are able to spend time innovating, building applications, and optimizing applications, rather than spending time on all of the operational tasks of database management, such as backups, upgrades, disaster recovery, provisioning, you name it. So you can focus on innovating while we, AWS, can automate and manage all of these operational tasks. Amazon RDS supports various popular engines: Oracle, SQL Server, Postgres, MySQL, MariaDB, and Amazon Aurora. Amazon Aurora is unique because it is a cloud-native database engine which was designed to provide you with the enterprise-grade security, availability, and reliability, but with the cost-effectiveness and simplicity of open-source databases. Due to some of Amazon Aurora unique features and characteristics, it is actually the fastest-growing service in the history of AWS, and tens of thousands of customers use it today. Now let's start to dive a bit deeper. There are actually several different levels of monitoring in Amazon RDS: instance level, operating system level, and database engine level. For instance level, we encourage you to use Amazon CloudWatch, which I'm sure many of you are familiar with. Amazon CloudWatch is the main AWS monitoring service for, again, monitoring and observability. And it allows you to monitor all of your AWS resources and your entire application stack. With Amazon CloudWatch, you can also monitor instance level metrics in Amazon RDS, such as CPU utilization, storage throughput, storage IOPS, network utilization, and dozens of other instance-level metrics. However, sometimes customers require deeper visibility into granular operating system metrics, such as Linux huge pages and swap activity. Maybe some customers require deeper visibility into operating systems, processes, and threads. And this is where Amazon RDS Enhanced Monitoring comes into play. We will also talk about this tool. But when it comes to deep dive database engine level monitoring and diagnostics, including SQL analysis and analyzing the SQL statistics and wait events, this is where RDS Performance Insights comes into play. RDS Performance Insights is going to be the main solution that we will talk about throughout today's presentation. For a more proactive and automated performance diagnostics, we have Amazon RDS, Amazon DevOps Guru for RDS, which is using machine learning to analyze past metric behavior and allow you basically get recommendations on how to remediate performance bottlenecks. So it allows you to be even more proactive when it comes to performance monitoring. I would like to start with the fundamentals. So Amazon CloudWatch, which we just mentioned, many of you are probably familiar with, also allows you to have monitoring and alerting. So you would like to get alerted and notified if there is any issue. It has an intuitive alarm wizard, which allows you to define things like metric threshold, evaluation period for alarm, what statistic to use to calculate the metric over that evaluation period. So for example, the minimum value, the maximum value, the count, the average, sum, etc. One of the things that is important to bear in mind is that threshold doesn't have to be static, right? So static threshold would be something like if we exceeded 100,000 IOPS for Oracle, for example, then we would like to get notified. So we get basically a specific value, specific literal value. Alarm threshold can also be dynamic, which uses machine learning that behind the scenes analyzes past metric behavior and creates a model of expected baseline range based on typical hourly, daily, and weekly patterns. So essentially, we know at any point in time what is the expected range of your workload. Let's see an example in this screenshot. So here we can see anomaly detection metric for RDS IOPS, RDS Oracle IOPS, read IOPS. And we can see the band, which represents the range of possible values. So as you can see, we know at any point in time what is the expected range. And by the way, you can make it more or less sensitive. So you can make it, you can modify it to be more or less likely to be triggered based on the business needs. While Amazon CloudWatch is great for instance level monitoring, sometimes customers require the deeper visibility into operating system level metrics, such as Linux huge pages and swap activity, and also analyzing processes and threads running at the OS level, which could be very useful sometimes when it comes to diagnostics and troubleshooting. This is where RDS Enhanced Monitoring comes into play. It's a fully integrated feature in Amazon RDS. In other words, you don't need to install anything, you just need to enable it. And behind the scenes with Amazon RDS Enhanced Monitoring, we actually deploy a local agent. So we collect the data directly from the instance level and not from the hypervisor. It has a default retention of 30 days, but you can modify it to be unexpired. And it also has a default resolution of 1 minute. Sometimes customers who require better or higher resolution frequency, they can change it to up to 1 second. So that's also something that you should be aware of. So far, we covered instance level monitoring and operating system level. But when it comes to deep dive database engine level and SQL analysis, including wait events and statistics for each SQL that is running, this is where RDS Performance Insights could be very handy. RDS Performance Insights helps you measure database load. What we have found, which is very common to see in the market, where many developers and DevOps engineers who don't necessarily have deep database expertise, they still find the tool to be very effective and efficient for diagnosing and resolving database performance challenges. Similar to RDS Enhanced Monitoring, it is also fully integrated and fully managed in Amazon RDS, so you don't need to install anything, you just need to enable Performance Insights, and you can benefit from deep dive advanced diagnostics and analysis. We just mentioned that Performance Insights measures database load. But let's talk about what exactly do we mean by that? What do we mean by database load? So behind the sessions, we are actually collecting average active sessions. And active session is a session that is running a SQL and is waiting for a response back from the database. So in order to have an informative picture of your database load, we collect the sessions and the SQLs, and we also collect other associated information like dimensions. And dimensions could be, for example, the database user who executed the SQL, the application that executed the SQL, the program, the application server, execution plans. So we can collect all of those additional dimensions. And one of the key dimensions that I would like to mention is wait events. Because wait event allows you to understand what is the root cause for a performance bottleneck. Put simply, wait events tell you why the SQL is waiting. And this is something we'll talk about throughout today's presentation. There could be many reasons, by the way, for wait events. It could be, for example, I/O latency when reading data from data files. It could be due to commit acknowledgement latency for commit acknowledgement from the storage subsystem. It could be due to table locks. So there could be various reasons for wait events. And Performance Insights allows you to indicate and find those wait events. As we sample the database every second, some engineers might be concerned about missing data in between. But what we have found is that the 1 second base frequency of sampling actually provides a very accurate representation of your database workload. And one analogy is in movies. When you go to the cinema, you watch X frames per second, and yet you get a very coherent picture. So in Performance Insights, we sample the data every second, but we allow you to get a very clear and coherent picture of your database workload. When it comes to performance, we always encourage customers to use Performance Insights to understand the deep dive analysis of the SQLs. And we also want you to think about the database as this big ocean of fish, and each fish is a SQL in the ocean. So typically, we would like to focus on the big fish in the ocean, those who contribute to most of your database workload. So for example, let's assume you have a SQL that is running in a duration of 10 milliseconds once a week. It's probably not going to be the one that is the most impactful for your database workload. So we encourage you to think about those who really contribute to most of the database workload. And the reason I also mentioned that is it's because important to understand that Performance Insights is not an auditing tool. Okay? Our goal with Performance Insights is not to collect and track every single statement that is running, but rather to collect every statement that is impactful for your database workload, that you could really understand how to improve performance bottlenecks. Capturing database load from multiple sessions is essentially what we're doing in Performance Insights. We are stacking concurrent database load from all of the SQLs that are running. And in this case, you can see a lot of sessions. We have 4 users. Each one runs SQLs. And by stacking the workload, we can see a graph that looks like that. This is the database graph. So we know exactly, using this graph, when the database was having a high level of concurrency and when the database was idle. But in this graph, you cannot tell why. And this is why the wait event breakdown could be very useful. Because as we mentioned earlier, throughout each query execution, we also collect all the various wait events. And by assigning different colors to each wait type or each wait category, we can provide you a very clear picture of database load over time. And this is how it looks like in Performance Insights. So you can see a screenshot here from Performance Insights, and you can see 2 spikes. We can see the first spike in green color, which represents CPU utilization. And we can see the other spike with the red color, which represents blocking locks. The average active sessions, the database load graph, can also be very useful to understand the state of the database. And let's look at some of examples. If the database average active sessions or database load graph shows 0, so no active sessions are running, you look at Performance Insights and you see nothing, it means that the database is pretty much idle. So if a user complaining is about performance challenges, the performance are unlikely to be because of database performance challenges. It's probably because of something else. When the average active sessions is below 1, it means that there are no major blocks. Imagine a user who is waiting because of a log for a couple of minutes. You would expect, by looking at Performance Insights, to see at least one average active session is waiting because there is one session that is blocked for a long time. But if you see that the average active sessions is below 1, it gives you an indication that probably there are no major blocks running in the database. When the average active sessions is below the number of vCPUs in the instance, so in this example, you can see the dotted horizontal line, we have 8 vCPUs in this specific instance type. And you can see that at 12:20, there were roughly 2 average active sessions, but the total number of vCPUs in the instance is 8. So we know that there is CPU available in the machine. But when we see that the average active sessions is higher than the number of vCPUs, like in the case of hour 12 and 5 minutes, which we can see 10 average active sessions, but there are only 8 vCPUs in the instance. This means that we have possible bottlenecks, and we need to either right-size the instance or tune the application or the database, because this is an indication, a flag that tells us we have a challenge, a performance bottleneck that we need to address. One of the benefits of the cloud, which again I'm sure many of you are familiar with, is elasticity, because it allows you to scale your resources as needed. Typically, customers would like to make data-driven decisions before doing right-sizing, before scaling the resources. What we have found is that many customers also use performance insights for right-sizing. So in this example, we can see that the CPU load is significantly lower than the number of vCPUs in the instance. So we can see the database load graph, and you can see mostly CPU because you can see the green color. And we look at performance insights, and this gives us an indication that we have a potentially oversized instance, meaning that we have a cost optimization opportunity here because we have an instance that is much bigger than the required database load. The reason I say potentially, by the way, and not definitely, is because there could be other factors like disk utilization, memory, et cetera, but it definitely gives us an indication that we have a cost optimization opportunity. We will need to run the numbers and do the testing, but this gives us a good understanding that we have an opportunity to reduce costs. On the other hand, if we see a graph that looks like this, where the CPU load is significantly higher than the number of vCPUs in the instance, then we have a potentially undersized instance. Okay, so this again means that we need to think about right-sizing, tuning the application, tuning the database to make sure that we don't have a major performance degradation or a performance bottleneck. One of the key benefits of performance insights is that we collect a lot of dimensions. We mentioned it earlier, like the application server, the program, the database user, the execution plan, et cetera. The reason it is powerful is because it allows you to drill down, slice and dice the activity by various dimensions. And by doing so, we can understand the root cause of a performance bottleneck. So for example, let's say we want to isolate the SQLs which were executed by user David and were associated with blocking locks. So these are some of the performance diagnostics activities we can do with performance insights very easily. And we can also see here a screenshot from the documentation showing the different dimensions which are supported to different engines. As you can see, there are different dimensions. Some are supported for several of the engines, some for most of the engines. It really depends, but we will continue to improve feature parity based on the market demand where it makes sense to do so. We are very driven by customers' feedback. So in general, if you have any feedback for specific dimensions that you would like to be added, or any other general feedback about performance insights, we will also love to hear from you after the session. Now I would like to hand it over to Maxim, so you will learn about the latest and greatest features when it comes to performance diagnostics, and also you will see a demo utilizing some of these newest features. Maxim, stage is yours.
Thank you, Penny. Well, over the last year, we've been working on a number of improvements to performance insights. And the underlying theme of these improvements is we want to make database performance simpler to understand. To achieve that, we are focusing on 3 separate things. The first one is that we are unifying user interface so that if you ever need to work with a database metric, you can find everything available right under your fingertips. Second, we are highlighting important pieces of that telemetry, putting forward the ones that have a higher chance to tell you something interesting about your database performance. And finally, we are introducing automated advisors that can highlight the problems that are otherwise might be difficult to see. So let's dive right in. Now, the first project that I want to talk about is what we call a single pane of glass. In a nutshell, single pane of glass is an evolution of Performance Insights user interface that is designed to combine all of the database telemetry together. As my co-speaker mentioned before, RDS database telemetry is made up of 3 separate areas. And these areas are the CloudWatch, the enhanced monitoring, and of course, Performance Insights. And up until now, these areas not only had their own metric repositories, but they also had their own display consoles. And that obviously created a great opportunity for us to improve things. So starting this August, there is a new way to access database telemetry in Performance Insights. Now, if you need to search for, work with, or access a metric in any of the database telemetry repositories, being CloudWatch, Performance Insights, or Enhanced Monitoring, you can find all of the telemetry in the same centralized location, and that location is Performance Insights. Well, there is still a slight problem with the telemetry, though, namely its size. On a typical database, RDS collects about 100 different metrics, well, if you don't count SQL-level metrics. And pretty often, and especially when you're in crisis mode, it might not be immediately obvious which metrics you actually need to look at to understand what your database is doing. So to help with that, we've worked with a number of experienced database engineers at Amazon and AWS, and we've crafted a curated subset of metrics, which are the most illuminating to describe database performance. And these metrics are now organized in what we call a database health dashboard, which we pre-built. And these dashboards are now available for all RDS engines that we support. Now, of course, you can also build your own dashboards, but now using all of the available database telemetry from all RDS telemetry sources. Another new feature, which was just released, I believe it was less than 3 weeks ago, is you are now able to take your Performance Insights dashboards and publish them to CloudWatch. And there's, of course, multiple reasons why you might want to do that, but one of those reasons is that CloudWatch has a very rich and well-designed graphical interface that you can use to tune your metric charts to the exact visual specification that you want. I'm just going to highlight a few potential capabilities here. So first of all, this is fairly trivial, but well, you can set thresholds on your metrics and annotate them. And you can set a regular rule-based thresholds as well as the more sophisticated anomaly detection thresholds. You can also change chart types, and CloudWatch right now supports many contemporary chart types that are available out there. This is my personal favorite. So what you can do is you can annotate your metric charts with relevant information For example, if you're working on a performance issue and you have a big team working on that, you can clearly communicate with the team and then maybe across teams as to how exactly that performance problem progressed in time, as well as what actions the team took to solve it and when. So this makes communication within the team and across team very simple and clear. You can also construct derivative metrics. Well, as I mentioned, on a typical database, RDS collects about 100 different pieces of telemetry, but obviously it's not going to collect all of them, all of the potential ones that are possible. But you can use math expressions to construct metrics from the underlying metrics and create new metrics. In this specific example, the database engine itself does not emit a buffer cache hit ratio metric, which we were interested in, but it emits the components for that, and we can use metric math to construct this metric. And the final thing is that you can share the dashboard with your teammates or, well, perhaps a leadership team. All right, so being able to work with the metrics, build the dashboards is obviously great, but the hallmark of any well-designed observability system is that you should be able to get alerts when things become sour. And what this means is that you probably want to set alarms on your metrics. CloudWatch already includes a pretty sophisticated machinery to set all kinds of alarms on metrics that it supports. But up until right now, you could only set alarms on the CloudWatch native metrics, but not the ones that are coming from performance insights or enhanced monitoring. Well, this changed starting this September. So now you are able to set alarms, and again, all kinds of alarms, on all RDS telemetry sources, including enhanced monitoring and performance insights. Probably the easiest way to do it is to, zoom on the metrics in the chart in the dashboard that you built, and then select and click on Edit in CloudWatch button. And once you do that, it will bring the metric into the CloudWatch realm, and if it's a performance insights or enhanced monitoring metric, for the time being, it will bring it in the form of metric math expression that uses dbparf insights function. Well, no matter what the form of the metric is, you can still set the alarm on it just like you would do on any other regular CloudWatch metric. For example, you can click on the alarm button and just follow the standard workflow to set the alarms. Again, very similar to what you would do for any, quote-unquote regular metric. Okay, so let's switch gears here and talk about a different project that we call Performance Analysis on Demand. Now, Performance Insights is already a pretty decent tool that can show you what your database performance looks like. But the thing is, the interpretation of what you see was always up to the customer itself, right? So we would show you what database load looks like, but it would be up to you to interpret whether the database is healthy or unhealthy. Well, in RDS, we wanted to democratize interpretation of this information. We want to make it easier for everyone to understand what these performance metrics are telling you. And that's why we came up with the idea of performance analysis on demand. So now you can go to your performance insights timeline and select any time range that you care about. And once you select it, a new button will appear with the name of Analyze Performance. You can click on that button, and within a few seconds, receive a performance analysis report that was generated for that time range. That report will tell you several things. So first of all, it will tell you whether the database is healthy or unhealthy, and if it's unhealthy, what is the level of that unhealthiness, how unexpected this situation is. It will also show you the nature of the problem that the database is experiencing in terms of wait events, and it will provide descriptions of what these wait events actually mean. Another thing it will point out is the major contributors in terms of SQLs that are, well, contributing to this problem. And finally, it may find correlated anomalies in major resources and tell you about them. So for example, it can pinpoint that the CPU has been exhausted, or memory was under pressure, or there was an unexpected and high spike of database connections, which is correlated to the time of the problem. And finally, for the most problem types that we recognize, we'll also link a contextual document that describes the next steps that you can take, how you can troubleshoot this problem more, and how you can, well, potentially address it. Well, so performance analysis on demand is an interactive experience, but there's also an automated way how you can detect database performance issues, and that is by using a DevOps Guru service. The DevOps Guru is a separate service under Amazon umbrella, and it monitors system telemetry continuously, and that includes all of the system telemetry that you register, not just database telemetry. And it will alert you if it finds anomalous patterns in any of the telemetry. Now, if the database is a part of that anomalous pattern, then DevOps Guru will also link a detailed database deep dive report, which actually looks very similar to performance on demand report. So it will highlight whether the database is having a performance issue and how big it is. It will record the nature of that issue and also highlight the main contributors to that issue in terms of SQL. And finally, it will also link similar documents that describe the next step that you can take to address the problem. All right, so let's do something fun. So let's take everything that we've seen during this presentation and use this to troubleshoot a real database performance issue. So we are going to look at the metrics, we are going to dive deep into some of them, and hopefully we can find the solution for our problem, or maybe several of them. All right, so let's set the context first. Now, imagine that you are an on-call engineer for an online web store. Your team, among other things, is responsible for the recent orders web page, right, where customers go and see their past orders. Now, when customers query their recent orders, their reasonable expectation is that these queries need to return fast. And your team's job is to make sure that this happens. Now, to get technical, the main driver for this page response time is a SQL query that goes to the backend RDS database and extracts the data for the page. And because this query is so crucial, you obviously monitor its performance very extensively and have all sorts of alarms in place. Okay, well, it's one of those days, and some of your alarms fire. This is a pretty big deal because many customers are complaining that their page refreshes became excruciatingly slow, and there are even reports that some of those requests are timing out. So clearly, that's not a good situation to be in, and as an on-call, well, you need to do something very fast to make customers happy. Well, whenever we deal with a performance issue, whether it's database or system performance, you typically need to answer these three questions. So first, well, what's going on? AKA the root cause of the problem. The second question is, who is responsible for that? If it's a human, so that we can talk to them, and if it's a machine, that we can find other ways to reason with them. But ultimately, what you want to, the answer that you want to find is to the question of, how can we fix it? So let's take these questions one by one. Now, to answer the first question, what's going on, we are going to look at the main performance insights page that shows the database load chart. And as you can probably see, there are some indications that the database is not behaving as well as it should, right? That big blue spike is the evidence of that. But we also have the new Analyze Performance button, so let's see what it can do for us in this case. So we press the button, and within a few seconds, we get a report that highlights three things. The first one is that the database load spike that we see on screen is both high and unusual, which confirms our suspicion that the database is not exactly healthy. The second finding is that the database load spike is dominated by active sessions that are waiting for I/O. We can deduce it by looking at the actual wait event, which in this case is I/O data file read. But the big picture is that the sessions are waiting for I/O, and that's the problem. And the third finding is also interesting. The system found that there was a correlated and unexpected spike of database connection that happened right at the same time when I/O problem happened. So all of this is useful information. Let's see what we can do with it. Now, first thing first, let's take a look at our I/O, because we noticed that lots of active sessions are waiting for I/O. And to do that, we are going to switch to the new metrics chart that shows the database health dashboard that I mentioned before. And this dashboard has multiple different parts. Some of those parts is dedicated to I/O metrics. And in this case, a couple of I/O metrics display pretty interesting behavior. So the first one that I'm highlighting here is I/O latency, or response time for I/O requests. Now, this is a typical OLTP system that we have. It's a transactional system. And within the bounds of that system, whenever you see I/O latency on the order of 500 milliseconds per request, you can probably say that it's, pretty unreasonable. But the second chart is even more telling in this case. And this chart measures the number of I/O operations that the database issues on behalf of our queries. And as you can see, this metric kind of plateaued or straight lined at a rather curious number of about 1,000. Now, I'm going to zoom this graph in so that everybody can clearly see what's going on here. And I'm pretty sure some of you already have a good idea of what exactly is the problem here. Any guesses? Yep. Thank you, sir. You're exactly right. So in this case, our database is using actually an IO1 EBS volume behind the scenes. And this volume has a set number of IO operations that is allocated to that volume. And in this case, it looks like we are well, essentially trying to cross that limit. And as a result, our requests are throttled. And that's why very likely we are seeing the latency on IO side. OK, so is that the only interesting metric pattern that we can see on this health dashboard charts? And the answer is no. We can actually see more patterns, right? So as you look for multiple metrics, you can see that many of them show very similar spikes that correlate very well to the time of the problem. Right, so I'm going to zoom some of them in to, again, make the patterns more clear to everyone. And it's a little bit subtle, but you can also probably guess what the main driver of bad IO performance is. The way to understand these charts, I think that the best way is to just read the names of the metrics and try to construct a sentence of what is happening with those metrics. So I'll start with the first one, right? A number of active sessions spiked during the time of the problem. Now, a number of database transactions spiked during the time of the problem, right? And I think you can see where I'm going with this. So essentially, we can say that the database workload spiked during the time of the problem, and that most likely that's what caused the problem in the first place, right? The database workload spiked, so we started reading more, issuing more IOPS to the EBS volume, and that's why the system became slow. All right, so we have the answer to question number one, what's going on. But who is responsible for that increased load on our database? And to answer that, I'm going to go back to the performance analysis report and look at the query that was the major contributor to the problem. Or you can alternatively say it's the query that is most suffering from the problem. So this is the query that we're looking at. And here comes our first big surprise. It's actually not our query, right? It's not the query that refreshes the orders page, right? So that query is on the right. And as you can see, this query is quite different from the one that is actually causing the issues. So we have this extra workload, which we are not aware of, that seems like it's making our database performance bad. But where does this new workload come from? So fortunately, in our system, our applications are well instrumented. And in particular, every time that a database connection is established, we also pass along the application name tag along with the connection request. And this is important because Performance Insights is well instrumented to use those tags. In fact, one of the database load dimensions that we support is by application name, which is constructed from these tags. And we can use that to identify which applications are causing increased load on our database. And once we switch to that dimension, it becomes very clear that, well, there is a new call center application which essentially overtook the the load on our database. The majority of database load is coming from that application. Right? So we found who is responsible for the problem. Just to have a quick summary of what we know so far is what's going on is there is a pretty acute I/O issue that is related to the fact that EBS volume IOPS have been exhausted. And we also found the responsible party for that. It's an extra call center application that started doing a lot of activity in our database and most likely caused that I/O spike to begin with. So how can we address it? Well, whenever you deal with a noisy neighbor situation, there's usually 3 ways how you can address that extra workload requirements. And this is assuming, of course, that that extra workload is actually needed. And in this case, we talked to the downstream team. So we talked to the call center developers, and they confirmed that, yes, it's a valid workload, and they want to run it. So our options are here. We can either tune the new workload, or we can find to coexist with this new workload somehow. Or if everything else fails, then we can move this workload elsewhere. So let's go through these options one by one and see what kind of solutions we can find. All right, so the first question, can we tune the new query? And this is probably the first question on any engineer's mind, right? So that's what engineers do. And fortunately, Performance Insights does provide SQL statistics that you can use to evaluate whether your queries are performing or underperforming. But the bad news here is that the numbers that we're looking at are quite small. And what this means is that this query is probably as efficient as it can be, right? So no major improvements there. We can dive a little deeper and look at this query execution plan. And if there are any Postgres experts here, they can confirm that, well, for this type of query, this is pretty much the perfect plan that it can use, right? So no major opportunities for improvement. And I have to mention that execution plans for Postgres databases is the only part of this investigation that is not yet instrumented in Performance Insights. But we do already have it instrumented for other engines, such as Oracle. All right, so option 1, tuning our extra query is a no-go. So let's switch and try to execute option number 2, right? So can we tune our system instead so that we can run both the original workload and the new workload on the same box? And there are several options that are available to us here. So the first option is fairly obvious. The original problem was caused by the fact that I/O capacity on the volume was exhausted. Well, maybe we can just add additional IOPS to that volume, and this will solve our issue. This sounds fairly trivial, but this is the beauty of running your database in the cloud, is that these operations are fairly simple to execute because cloud gives us that flexibility to add capacity on demand. Now, obviously, we'll need to run some numbers here, but that's a potential solution number 1. Solution number 2 is, well, let's try to look at our query specifically, the query that refreshes the orders page. And in Performance Insights, you can reconstruct your database load chart to show only activity that is specific or scoped to only a single query. You can do it simply by clicking on the query in the bottom tab in Performance Insights, and this will rearrange the graphs for that query only. And here what you can see is that, well, the database load spike for our query looks almost exactly like the database load spike for our database, right? So there's a bunch of sessions that started to waiting for I/O when the problem began. But the important piece here is that our query was not waiting for I/O before the problem began. And once again, we can confirm that the query statistics will show us that execution rate for this query, for our query actually did not change, right? So it's just the effect of noisy neighbor that caused this behavior to change. And we can confirm what our query load profile looked like before the problem by zooming in Performance Insights on the time of the problem and looking at the resulting weight event distribution. And in this case, you can see that the query was clearly running from memory, right? So there's barely any I/O-related weights in this picture. Okay, so what changed? And what's the conclusion that we can make by looking at this graph? Well, the rather obvious conclusion here is that our database box was sized pretty well for the resident set size of our query before extra workload came in, right? So the query was running mostly from memory just because the box was finely tuned to handle that workload. And then once the new workload came, it pushed both itself and our query out of memory and to start using disk requests. Okay, so if that's the explanation, then the rather simple solution here is to potentially just use more memory, right? To put it simply, we can put this database on a bigger box, and this may solve our performance issue. So obviously, we need to run more numbers here and perhaps do some experiments, but that's a potential solution number 2. So we have our 2 solutions, but let's still be thorough and see if we can also explore whether we can move the new noisy neighbor workload elsewhere. Now, to do that, we are going to look at our neighbor query again. And what we can notice is that, first of all, it's just a single query, which is great. And it's also a select query, which means it's read-only, right? So it's even more great. And what that means is that there is a good opportunity here to perhaps run this new extra workload from a dedicated read replica or several. We do need to, again, talk to the downstream team and see how this can be done and or whether they have dependency on the timing of this query in different parts of their application. But it's a potential solution number 3. And there's even one more potential solution here, right? So instead of using read replicas, we can perhaps cache results of this query in something like Amazon Elastic Cache, right? So, and we can apply this logic to both the new query and our original query to make sure that the response time of these queries remains in the acceptable range. And that concludes our investigation. So we looked through multiple options, and we were able to find some solutions that we can apply very quickly, like adding IOPS to the volume to perhaps stop the pain. And we also found some other solutions which are more elaborate, but that can potentially address the problem better long term. So we do need to talk to downstream team and run some experiments, run some numbers. But there are, well, at least there are several ways that we know how we can address the performance issues that we're seeing. And as you can see, performance insights helped us run through this investigation and then provided valuable insights, right? So we were able to look at the system overall holistically. We were able to dive deep and look at specific metrics. And we were able to eventually find the solutions based on the evidence that we saw in Performance Insights. So the bottom line is Performance Insights was a big help. And here is hoping that the same Performance Insights toolset can help you guys in your own performance investigations and performance journeys. And with that, I'm going to give the mic back to Pini.
Thank you very much, Maxim. This demo definitely utilizes some of the latest and greatest performance diagnostics features. And it shows you how utilizing the latest and greatest features can simplify performance diagnostics and troubleshooting, so you don't need to work too hard to identify performance bottlenecks and resolve them. I will just summarize by saying that database performance is all about visibility. And as we said in the beginning of the presentation, you can't fix a performance bottleneck that you can't see. So we encourage you to take advantage of the features that are available for you, the services and tools, and aim to be more proactive. So for example, we talked about the dynamic threshold in Amazon CloudWatch, which analyzes past metric behavior and know what is the expected baseline range at any point in time and can notify you about deviation from the baseline. Maxim showed you some features which allow you to be more proactive, like exporting performance insights metrics into Amazon CloudWatch. So now you can be alerted on performance insights metrics, which is a very significant announcement for performance monitoring. We also discussed about exporting performance insights dashboards into CloudWatch. So now you can use CloudWatch dashboards, you can share it with your team, and you can be more proactive. So the bottom line is take advantage of these tools, find the right tool for the right job, and aim to be more proactive. One last note before we finish the session. As you know, AWS is a data-driven company, so getting your feedback would be extremely valuable to us. If you can spend a minute and provide us feedback in the survey, that would be great. Thank you so much for attending. Maxim and I will be outside of the room just to respect the next speaker, so if you have any questions to ask, we would love to get your questions, and enjoy the rest of the conference.